So thank you for coming here. Thank you for the invitation to speak about this topic, nuclear proliferation. Thank you for the kind introduction. One thing I remembered as you went through my education at UCLA, I was a student of George Igos, and his thesis advisor was Luis Alvarez. You may know him as the physicist who won a Nobel Prize for the bubble chamber, but he worked on the Manhattan Project. He actually was on one of the planes that accompanied the Enola Gay on the way to Hiroshima. His responsibility was to measure the energy output from this nuclear explosion. Today, our focus is going to be mostly on the possibility of nuclear terrorism. So I will start with a brief intro to what the problem is, what nuclear weapons are, what the impact of nuclear weapons is. I will do this using a hypothetical example, a terrorist attack on Chicago, and then we will discuss whether this scenario that I present to you is realistic, if this is something that really might happen one day, that could happen. We then will see that one particular important point that, in my opinion, doesn't get discussed enough is the problem of perfection with advanced technology. We have a technology at hand that can wipe out entire cities, and we cannot afford the smallest mistake. A probability of 10 to the minus 5 that something goes wrong, 1 in 100,000 is already too large. And one question we have to ask as humans, can we really own and operate and control a technology for centuries and millennia to come without being perfect? And in that context, I then also will discuss the problem of accidental nuclear war and the consequences this would have worldwide. So let's recall how powerful nuclear weapons are. Think for maybe 5 seconds for yourself how much more powerful nuclear weapons are to conventional explosives. Let's say we have a gram of TNT and a gram of uranium-235 nuclear explosive material. How much more energy would we get from the uranium? And the answer to this, a staggering 1 million more times energy. That is something that's not so easy to grasp. And I try here to help us along with this a little bit. I want to look at a conventional explosion that the United States Navy carried out in 1964 to study to what extent naval vessels could cope with nuclear warfare. So they piled up 500 tons of TNT in what was called Operation Sailorhead and exploded it. So here's the explosion. This is the test Navy vessel. You might see from the condensation here and also the alteration on the ocean surface, how the shock wave expands. So this is 500 tons of TNT. In order to attack a city with this sort of destructive power, one needed 50 bombers, each carrying 20 bombs of 1,000 pounds of TNT. So if we now scale this to the first nuclear attack carried out by the Enola Gay onto Hiroshima with a total nuclear explosive power of 15 kilotons, 15,000 tons of TNT, we see that we would need 1,500 bombers, each carrying 20 bombs of 1,000 pounds of TNT. So 30 times this amount here. You also might think of 30 piles of 500 tons of TNT distributed throughout the city of Hiroshima. What are the effects of this? They are truly horrifying. This is a picture that has been taken after the attack on Hiroshima. You may know that in traditional Japanese cities, most of the construction is wood frame, so that is particularly vulnerable to a nuclear attack and the resulting fires, possibly a firestorm. And immediately during the explosion and the immediate aftermath, more than 65,000 people were killed, more than 69,000 were seriously injured. So this is a very serious weapon. In fact, nuclear weapons are the only weapons that can destroy a major city and kill hundreds of thousands of people instantly. Modern nuclear weapons, such as they are on United States missiles, can have a yield that is 100 times or 1,000 times stronger than this. So in some sense, what we're looking at here is a relatively small nuclear explosion at the scale of what's possible. So nuclear weapons can instantly kill hundreds of thousands of people. And nuclear weapons, if used in an all-out nuclear war, are the only weapons that are capable of destroying literally a functioning society and to destroy its social fabric. If you think of this particular explosion and the injured people here, you have 60,000 people that have third-degree burns, that have lost their eyesight, and the hospitals where you want to treat them are gone. There are no doctors, there are no nurses. Help has to rush in from other cities, from outside. Now imagine an all-out war. In this case, this help is never going to arrive. In that sense, we say that an all-out nuclear war has truly the capability of destroying society. So obviously, the international community under American leadership was aware of the tremendous impact this new military technology would have on the world. And in reaction to this, the United Nations tried to come up with a diplomatic regime that would contain this threat. And the result of this is the Nuclear Non-Proliferation Treaty, the NPT, that was signed in 1968. And it basically divides the world into two groups of nations. There's the group, the nuclear weapon states, that had developed nuclear weapons by the time of the signing of this treaty. They are listed here, the two superpowers, the United States and Russia, but also the United Kingdom, France, and China. And then everyone else. And everyone else agrees to not develop nuclear weapons, but in return, they would receive assistance from the nuclear weapon states in using nuclear technology for civilian, for peaceful purposes. I think President Eisenhower at the time, who is the initiator of what's called Atoms for Peace, saw very clearly that one cannot keep nuclear technology away from countries. There are many very positive civilian uses. So a way has to be found to separate military from civilian use and to control the civilian use of nuclear technology. And that is actually the purpose of what's called the International Atomic Energy Agency, IAEA, in Vienna. It's a branch of the United Nations. All countries contribute to the IAEA with technology, with scientists, with inspectors. The IAEA has the ability to monitor nuclear facilities in all countries around the world. A particular interesting problem right now is Iran. I believe the IAEA has something like 170 inspectors on the ground there at any time. And they have very powerful technology. For example, their environmental sampling can pick up 10 to the minus 15 grams of plutonium or uranium. It's basically impossible to hide or conceal a nuclear facility from this agency. So now I want to briefly explain to you where this destructive power comes from. It's actually relevant for us to know because it plays a big role in our attempts to restrict nuclear proliferation. If we don't understand what materials are needed, we can't restrict the technologies that are needed to make sure that these materials are not spreading out and used widely. So the energy source is of nuclear nature. It's the energy that's freed when nuclei split apart. And it turns out that certain nuclei can be induced to split if they are bombarded with neutrons. One important nucleus of this kind is uranium. And what's shown here is an example of an uranium fission reaction. There's a neutron that's incoming on the uranium nucleus. the uranium nucleus splits apart into two daughter nuclei. We call them fission products. And then there are additional neutrons that are liberated from the parent nucleus, the uranium, or the daughter nuclei during the fission process. Now, these neutrons travel on in the material and might hit a second nucleus. And then this nucleus can undergo fission and will set additional neutrons free. And as we in uranium get more than one neutron, we get 2 or 3 typically, the number of reactions will dramatically increase. And we get a chain reaction. It turns out that this works only for one particular isotope of uranium. What do I mean with isotope? It's the mix of protons here in red and neutrons in the nucleus in gray. So if I say I'm dealing with uranium isotope 235, I mean I have a nucleus that has 235 protons and neutrons combined. There's also uranium-238. It has 3 more neutrons. Uranium-238 cannot be used to sustain a chain reaction. Now, this is really important for proliferation. It turns out that the natural occurring uranium is a mix of uranium-238 and uranium-235. It only contains a very small fraction of uranium-235. And for nuclear applications, we have to enrich this to a fraction of over 90%. This is what we call highly enriched uranium. So only if we somehow manage to enrich the uranium-235 to 90%, we can get this chain reaction. Let me show you a small experiment down here to illustrate how these chain reactions work. This is a cage full of mouse traps. I know it's not what you have at home, but trust me, nuclear physicists do. So each mousetrap is loaded with 2 corks, and I have here my initial neutron that will initiate the first fission reaction, and then additional fission reactions will be triggered. Let's hope this works better. So this was slow, it was a second or so. In the case of the nuclear interaction, it's super fast. The time scale for one interaction is 10 to the minus 24 seconds. And we get something like 80 of these reaction chains in less than a microsecond. Meaning, if I have a nuclear explosion here where I stand, a millionth of a second later, I have this enormous amount of energy in an extremely small volume. That's why it's such a forceful explosion. So how is highly enriched uranium obtained? Well, for this, one needs some really fancy technology. Chemically, the 2 isotopes, atoms with the 2 isotopes are basically identical. There's no way they could be separated with a chemical reaction. So the only way of doing it is exploiting the tiny difference in weight between atoms that contain an uranium-235 nucleus with 3 neutrons less than uranium-238 with 3 neutrons more. And that is what ultracentrifuges are used for. Here is a ultracentrifuge plant, I think in Natanz, in Iran. And it turns out that this is very difficult technologies. They revolve at hundreds of thousands revolutions per minute. The forces are enormous. The materials are very difficult to develop. It's actually a technology that can be controlled easily unless someone sells it, in this case, to Iran. So this is basically the one place where we can interrupt the proliferation of nuclear materials and nuclear bombs in the most efficient way. So now to my example. Maybe it's a good time to ask if you have questions on how a nuclear weapon works, where the energy comes from. Yes?
You mentioned earlier that there was no way to significantly reduce the
I see. So the question is, we can't do anything to reduce the death toll by measures before or after the explosion. Could we move the nuclear weapon elsewhere and explode it there? And I think the image you have is that this is a nuclear weapon deployed by a terror organization, and we still have time to basically drive it somewhere else. And that is possible. We also might be able to defuse it. I think a good measure would be to explode it. Obviously, you would contaminate the city in serious ways in the immediate surrounding, but that would be much better than having it go off. Then I also should say, in real military applications, the nuclear weapons typically come at the tip of a missile, and an intercontinental missile comes in at a velocity of about 7 kilometers per second, and there's pretty much nothing we can do. The United States is pushing hard to develop missile defense, but I think it's still not very successful. Yes? So you want to take it out of space? They have tested weapons in space, but I think it would be taking some time to put this on a missile that would take it into space. But if it exploded there, we were protected from the impact here on the surface of the Earth. That's correct. It turns out that our atmosphere is a fantastic shield against radiation. There's actually many natural sources of radiation that bombard Earth every day. And if it wasn't for our atmosphere, we had very high radiation levels down here. So let me go to my example. Yes?
Real quick, did Iran sign the non-proliferation treaty?
Yes, Iran did sign the non-proliferation treaty, but it was found in violation with the non-proliferation treaty by the IAEA, I think in 2003. That's basically at the beginning of the current development. And in the present Iran nuclear deal, Iran actually promises to long-term obey basically the non-proliferation treaty. And the IAEA has the means to monitor this. So the question is, what happens if the IAEA again detects a violation of the NPT as it did before? So here's my example that lets us study the impact of nuclear explosions. I'm thinking of a terrorist group that is upset about NATO's intervention in Afghanistan. And so they try to find a high-profile target that represents NATO, such as the NATO summit that took place in Chicago in 2012, I think at McCormick Place, and had all NATO heads of states present. And the utility they are interested in nuclear weapons, as long as they bring these nuclear weapons within a few hundred meters, they can kill everyone. There's no escape. We just discussed how there's nothing that can be done to protect these heads of states against a nuclear weapon that's set off in the vicinity. So how would they go about this? They would smuggle fissile material and other weapon components illegally into the country. They might seek to obtain this at some black market for nuclear materials in Pakistan or maybe in former Soviet states. We'll see in a little bit that there are issues with guaranteeing the security in certain countries of nuclear materials. They would rent a shop or a house, either in Chicago, maybe nearby in Milwaukee, and then assemble the nuclear device. Then one day, they would drive with a truck, say on South Michigan Avenue, and at the corner where you take a turn east to McCormick Place, they would set off this nuclear device. So what are the consequences of this? I should say I have chosen a nuclear weapon that is actually of a typical size that experts think terrorists could build. It's 10 kilotons of yield. It's smaller than the weapons that are used by the military today. Before I show you, I simulated the aftermath of the explosion. Before I show you this, I want to show you this news clip from the Chicago Tribune. This is not about international terrorism. These were 3 domestic criminals who actually were caught planning an attack on the NATO summit in Chicago. It was not a nuclear attack, but I thought I'd show this to just demonstrate that this idea is not completely out of the blue. There are people who, unfortunately, consider doing things like this. So now let's look at the explosion. I use a simple simulator provided by Alex Wellerstein at Stevens Institute for Technology. What I did, I placed a 10 kiloton weapon at the corner of, I think, South Michigan and Cunningham. I'm not quite sure I remember the names. And what we see here now are different areas of destruction. For example, this yellow circle that you see inside is the fireball that's formed. The energy that's liberated literally sets the air on fire. At the surface of this fireball, we reach the temperatures of the surface of the sun. And then, since this is a terrorist attack carried out with a truck, this is a ground burst, and what that means is that a lot of radioactive material is thrown into the atmosphere and then comes down, downwind from the explosion site. And the color code that you see to the southwest of ground zero shows us different levels of radioactivity. And I have listed down the details on the next slide. So let's look at the fireball first. This is going to have 650 feet of radius, actually, so the diameter is 1,300 feet. And literally everything in this fireball instantly will evaporate. All of McCormick Place. I selected the explosion site such, it's a public street that the police cannot shut down entirely during an event at McCormick. And it's close enough so that McCormick is entirely in the fireball. Then there's a massive blast wave. Initially, all this energy, or most of the energy, is in electromagnetic radiation, in gamma. This interacts with the air, it heats up the air expands rapidly, and after a very short time, half of the energy that has been released is in a shock or blast wave. And it turns out, from a military point of view, that's the most destructive part of a nuclear explosion. So for example, within distance of 1,500 feet, the pressure reached in this blast wave is greater than 20 psi. Now that flattens even hardened concrete structures. So even if we miss to evaporate one of the heads of states, once this blast wave hits, that will be hit. Then if we are 3,200 feet away, the blast wave pressure has dropped to 5 psi. That's still enough to destroy residential homes. It's not enough for commercial steel or concrete buildings, but anything residential will be completely destroyed. Everyone in this radius will be severely injured, most of them actually fatally. Then we have to worry about direct radiation. This is the radiation that's set free in the explosion. I have noted down here the area or the distance in which this radiation level is greater than 500 rem. It's a measure for how much, it's an equivalent dose measure, how much radiation a human has suffered and what the biological impact is. One thing it lets us tell, above 500 rem, more than 50% of the people affected will die in the following days or weeks of radiation sickness. Then there's an enormous amount of thermal radiation. I have mentioned how this fireball is as hot as the sun. We know that the sun radiates out a lot of energy. It is not healthy to be within a few miles of the sun's surface, even a few thousand miles. And similarly here, the thermal radiation actually will cause third-degree burns to anyone who is within 4,600 feet of this explosion. Here it makes a big difference where people are. If they're inside a building, they will be protected. One thing I haven't written down here explicitly, what makes a very devastating impact on the city at large is the combination of this thermal radiation and the blast wave. The blast wave basically chops the wood, and then the thermal wave will set it on fire. And the same is true for gas in tanks in vehicles or oil tanks. So immediately after this, the city basically will be on fire. It depends a little bit on the construction that's used, but that is the effect. Yes?
So basically, as you make counterintelligence, this attack, you know that these will be consequences, and where will be, and like you managed to intercept the truck before it gets to Chicago, where will be the safest? Would you put it like 5,000 feet away and then evacuate the city?
Right. Actually, so definitely the government tries to do something there, but everyone agrees that the right place to interfere with this is at the creation and the distribution and the availability of the nuclear material. That's the most difficult thing for them to meet, and that's where we really can interfere with a terrorist effort to carry out an attack. Then certainly people will have radiation detectors installed, they will monitor, there's now networks of radiation monitors in large cities. But just think of other illicit criminal activity. People bring drugs into cities, you know, they abduct people and bring them in or out. Of course the police catches some of this activity, but the probability for this is not 100%. So there's no perfect defense once this weapon is in the hand of terrorists. Yes?
What would be the size of such a device?
So, yes. What's assumed here is that it's a low-tech device, that the terrorists have assembled a team of people who are not experts in this, scientists and engineers and technicians, but not experts. And it's kind of thought that the device is somewhat similar to the original devices that were used in World War II. And you might think of it as in size as big as this podium, and in weight it would be a ton or so. Killed immediately in this weapon, and this has to do with why is this less than Hiroshima? The reason is that McCormick Place is not close to densely populated areas, but still it's a very large number of people, and many are injured. So let's look at the processes. We see here the fireball in red, and the fireball is a little bit like a hot air balloon. The density of hot air is low, so it will rise up into the atmosphere. It will rise very violently. The velocity I show here is not representative of what it really does. It actually rises with hurricane speeds or in excess of hurricane speeds. And if we have a ground explosion, the fireball will evaporate lots of dirt, building material, asphalt. All this will be pulled up into the air. And all of this will actually capture radioactive particles that were generated in the explosion. So if we have a ground explosion, we have tons and tons of material that's pulled up this chimney and is turned into highly radioactive material. It then travels with the wind and slowly will fall out to the ground. And this is what we call radioactive fallout. So in this particular simulation, this is not quite typical, but I had the wind come from the northeast so that we can see the plume. This faint yellow area is the area that will gather fallout, producing a rad per hour. The affected area is 320 square miles. Then the next color code here is everything that has more than 10 rads per hour, 150 square miles. And then the last here is at 100 rads per hour, about 20 square miles. To give you a scale of what problem this poses, if you stay in this area, if you don't immediately evacuate, after about 5 hours, you will have a lethal dose that you cannot survive. frankly, I don't think, I think that the government in a case like this had to evacuate everyone within this area. Actually, it had to go well beyond this, depending on how much radiation people are willing to suffer. I think this really depends on context. In peacetime, we should set these limits very low. If it was an all-out nuclear war, I think there may be no better place to go to anyway, and people had to accept relatively high radiation levels. So I think at least 300 plus square miles of land that cannot be occupied, that cannot be farmed for many years to come. How long? This is difficult to answer. We have not had this situation. Hiroshima and Nagasaki were air blasts. This gives more damage in terms of blast and thermal radiation, but it doesn't produce as much fallout. One thing I did in order to estimate how long this might take, I looked at the first Soviet ground test. There's a team of Japanese scientists who have gone there after the fall of the Soviet Union and have looked in a village, I think Dolon village, that's 110 kilometers away from ground zero. And they have taken many ground samples and analyzed them. And from that, they were able to obtain the dose in Dolon, 110 kilometers away, as function of time after the explosion. So this is how much radiation you get. This levels here are absolutely lethal. And then this is after 1,000 days. And it actually turns out that if we introduce a standard where we say people would return to an area after the radiation has dropped below the highest level of natural radiation that we observe on the Earth, then it would be 7 to 10 years before this could be populated again. So now, so far the hypothetical scenario. Now the question, can terrorists really get their hands on a weapon like this? Yes?
I'd like to propose, in addition to the effects of the nuclear weapons, the primary effect we have planned to consider up in the Chicago area or anything, even for a 5 kiloton weapon, much less a 10 KT, is the EMP.
Yes.
Because today, everything is now solid-state electronics, so all of that stuff is just, it's history. And it'd be a far larger region that'd be way up into Wisconsin, way down to our area would be affected.
Yeah, so this is a very good point. So we have an electromagnetic pulse, because there's a lot of charged particles. Very strong electromagnetic waves are emitted, and they induce currents in electronic devices. And these currents can be so strong that they destroy these electronic devices. And one thing that could mean...
you have no transportation, no communication.
Yeah, for example, the fire brigade in Evanston may decide to come to the rescue, except that their trucks won't work. Yeah. So that's a very good point. Mm-hmm. But in terms of impact, so in the aftermath, this has a huge impact. But in terms of the loss of life, it's not the most important effect. But in terms of bringing in help from nearby resources, it certainly matters a great deal. So are there people who are planning nuclear terror attacks? Maybe I was brought up in a golden cage and just too fearful of the world out there, and I'm making up a fearsome scenario. However, there's hard evidence not only from United States intelligence agency, but also in agencies of allies, France, Britain, etc., that there is at least 4 terrorist organizations who have seriously sought to acquire fissile materials, nuclear explosive materials. Intelligence agencies also have looked at who might have the capability of developing a low-tech nuclear weapon. And then there's also Hezbollah and Taliban, in addition to Al-Qaeda, the Chechen-based separatists, Lashkar-e-Taiba. This is a Pakistani terrorist organization that largely attacks interests of India and Kashmir. This is a Japanese group that actually carried out a chemical attack in the Tokyo subway system. So who has been caught in trying to buy nuclear materials? So far only 2 of these organizations. Do we know anything about plans? that they have basically a game plan how to do this. And at the very least, there is one by Al-Qaeda. Al-Qaeda is actually now trying for more than 50 years to acquire nuclear materials and to build a bomb. And I think that most Western and Russian intelligence services agree with this statement. So pathways to a nuclear weapon, we already learned that it's very hard to make a nuclear bomb. But there are really hundreds of sites that have highly enriched uranium around the world. There's alone 130 research reactors that have highly enriched uranium. The US Office of Technology and Assessment also has found quite some time ago already, 40 years ago, that technically it is possible for a group of technicians, engineers, and physicists that somehow hire on to a terrorist organization to make a simple nuclear device. And I list here how much HEU there's really out there. It's 1,600 tons and 500 tons of plutonium. So there's lots of material that has to be guarded and safeguarded in many different settings. It turns out that there is precedence that fissile material or even bombs have been lost or stolen. So far, we think that 100% of the stolen material was recovered, except that in an IAEA report, 2009, it is stated that we are not certain all the known missing material has been recovered, but they are not certain that all the losses are really known. Have terrorists acquired fissile material? Not to our current knowledge. There are no known cases. Then I think it's worthwhile to go through examples where we're very vulnerable towards HEU or plutonium. So, for example, in 1993, 20 bombs worth of HEU was discovered in Kazakhstan, in a facility that in the aftermath of the split up of the Soviet Union was not longer guarded adequately. So with relatively little force, a terrorist organization could have gone in and secured this material, or some of it. In 2006, a Russian citizen was arrested in Georgia with 100 grams of HEU that he tried to sell. And he claimed that after this initial delivery, he would have a significant additional quantity that he could provide. South Africa had a nuclear weapons program at some time. In 2007, two armed criminal teams broke into a nuclear facility where there was enough HEU for 30 weapons. They managed to get past the security fences and entered the emergency control center. They shot a worker and then escaped without taking material. This is an institution I collaborated with, Kurchatov in Moscow. What you're looking at here is their high-flux reactor. At the time where this picture was taken, there was enough HEU in here for a nuclear warhead. It was not really guarded by or protected by a fence. Obviously, this is the past. The United States and Russia have collaborated very closely to improve this. This is not how this looks right now. So there's interesting additional examples for vulnerable stashes of fissile material. The United States still has tactical nuclear weapons in Europe, Belgium, Germany, in Turkey. Some of it is, I think, within 70 or 80 kilometers of the border with Syria. And the security standard at these facilities is not thought to be at par with the security that is demanded here in the United States or by most of its allies in Europe. And there's an example that in 2010, 6 anti-nuclear activists broke into a Belgian military base where 10 to 20 warheads are stored, and were able to be in this base for an hour before they were arrested. All that is saying is if this was a malignant terrorist group, they would have had plenty of time to look for this weapon. even the potential for sale exists. So for example, we know that Kim Jong-il sold an entire plutonium reactor that was just to be used by Syria to make weapons-grade plutonium material. Yeah, how come this is actually an interesting problem? Let me see if I can show you this quickly. Selling a weapon is a very tricky thing. There's something that we call nuclear forensic. Now, if I was to buy a nuclear weapon from Russia and detonate it here in Illinois, the United States could immediately tell where this comes from. By the isotopic composition, we know where the ore was mined. We actually know where it was processed, what kind of reactor maybe was involved, depending on what the weapon is. So nuclear forensics makes it possible to attribute a nuclear weapon to its source and then to retaliate reliably. We would not hit the wrong country. So why would anyone be willing to sell this? And I think the one exception that we have right now is maybe North Korea. This is an article from the LA Times that analyzes their nutritious situation in 2012. I quickly explain this plot here. This is time. This is if they have enough food for their population or not. The zero line, if that's met, it means that the supply meets the need of the population. Whenever a line is below this, it means there's starvation. So for example, here from 1995 to 1998, we don't know exactly, but it is thought that between 500,000 and 3 million North Koreans died in a serious famine they had. And this is a time where the United States negotiated food aid with North Korea in 2012. And this article points out that if you take different models from different think tanks, basically they all predicted a famine in North Korea, and that this food aid that the United States may have provided actually would have been enough to close this. And the interesting observation one can make in this context, if you look at the value, the amount of money that would be needed to buy this food that's necessary, it was roughly $1 billion, and that roughly is the kind of money that is thought Al-Qaeda might have available to acquire fissile material. So a regime that's desperate in seeking survival may actually do something that anyone sane would not do. They, of course, know exactly that we will know it comes from North Korea. But if the situation is dire enough, they might compromise. Next, has a country ever lost nuclear weapons? The United States has the world record here, but I think it's mostly for the reasons that the Russians don't report what they have lost. 11 American warheads have been lost. It is known that 4 Russian subs that were nuclear armed sank and were not recovered, including the weapons that they have had on board. In fact, if we look at the summary for a period from 1993 to 2008, the IAEA had 421 incidents where nuclear materials were lost, stolen, or lost by its member countries. And 18 were actually confirmed incidences where this was highly enriched uranium or plutonium. So then I think I want to show you 2 cases that are domestic and I find interesting. This now has to do with what I said in the beginning, the challenge to be absolutely perfect in guarding nuclear weapons and in making sure there's no malfunction forever, for as long as we have nuclear weapons. This here is an image of the Y-12 nuclear facility at Oak Ridge National Lab in Tennessee. There's a lot of HEU stored there. We don't know this exactly, but the building that's interesting in this particular context is thought to have 400 tons of HEU. There was a group of 3 peace activists, Sister Megan Rice, Michael Wally, and Greg Borty-Obed, who managed to advance through several layers of security fences to the walls of this building. They sang peace songs, they painted the walls, and after, I believe, only 15-20 minutes, security forces intervened. Now guess how old was Sister Megan Rice when this occurred? 80? Did someone say 80? That's right. So what do you think of the security? Yeah. And of course, this was very embarrassing to the United States government. So Sister Megan Rice and her peace activists were thrown into prison, despite the fact that they did this country a service in pointing out this very serious security breach. If that had been serious terrorists, I'm not sure the government was in a position where they could guarantee the safety of this material. One more example that goes in exactly the same direction. I think this happened in 2002. There was some cruise missiles that were to be scrapped, and they were to be flown by B-52 from Minot Air Force Base in North Dakota to Barksdale Air Force Base in Louisiana. And the missiles were loaded and unknown to anyone. 6 of them had nuclear warheads on them. They spent some time loaded on the plane before starting, and then I think 24 hours after they had arrived. What was discussed in the media at the time the most was this flight of nuclear weapons across the country. I don't think that this was a significant security risk. The issue really was that there were 6 nuclear weapons of, I think, 100 kilotons each that were unguarded for 36 hours, 150 kilotons, thank you, that were unguarded for 36 hours. They were on a military base, but the level of security on a military base is much smaller than the level of security that the law requires for nuclear weapons. Basically, the level of security required for a nuclear weapon is that even a very dedicated and fierce group of terrorists has no chance to extract a nuclear weapon. And that certainly was not the case here. So I'm not saying at all that these are bad people or bad units. I actually think they're all very hardworking and do their very best. The problem is more fundamental. Humans are not perfect. We always will make errors. And if we wait for long enough, an error will occur. We will lose a nuclear bomb to a terrorist organization or a material. Here's another example that I think illustrates how challenging it is to have a group of people of which you require perfection every second, year by year, decade by decade. This is an article from the New York Times that shows that a group, I think, of 34 Air Force officers cheated on a proficiency exam where they tested on procedures for nuclear security. And afterwards, I think what was argued is that this is kind of hard to avoid. If you're under this strain for many years, this is a test where they have to get everything right. They always have to be perfect. That is inhuman. People make mistakes. And with nuclear weapons, we cannot afford mistakes. So I now want to ask, can I have 5 more minutes or, yeah? So we now look at this problem that nuclear weapons, in my opinion, require perfection in dealing with them, in protecting them, in making sure that they're only used exactly the way our political leadership wants to use them, and not by a terrorist or, say, a rogue member of the military. So one problem that I want to discuss next is the possibility of accidental nuclear war. Yes?
Yes, how big physically would this have to be? You load up a big guy with a big backpack and put him where you want him to go?
So this here is what does it say? An MK-12A. This is a warhead that would be loaded on a ballistic missile of more than 300 kilotons yield. So that's the size of one device. So I think you can't walk away with it. You had to bring a truck, but it's not impossible. Yes?
Do you think stage break-ins at the nuclear facilities as a security test? Would people get paid for pretending to break into the facilities to test the security?
Well, I think Sister Megan Rice should have asked for money. You're exactly right. I think they do things like this, but within reason. So I shouldn't say this so easily, but Sister Megan Rice actually should have been dead. You know, by the time she passed the first safety fence, or the second, I'm not exactly sure, but at some level, the response has to be lethal force. And I think it has to be lethal force without fail if you protect nuclear weapons. It's not my preference, but I think that's absolutely necessary.
What's the minimum amount of nuclear material it would take to make a 5 or 10 kiloton bomb?
So the 10 kiloton bomb for Chicago would require 25, 27 kilograms of metallic uranium. Yes?
James warheads, their fission, you said it was fission, but fusion bombs have also been created. So if we have any of these, do these statistics account for fusion bombs or fission?
The ones that are listed here to a very large extent are fusion bombs. Each fusion bomb, however, has a fission primary stage. We don't think that terrorists can build a fusion bomb. That is actually very challenging. Countries can, but terrorists can't. I also should say, so that people are not too pessimistic, if I stole this, I actually could not set it off. There are what's called PALs, permissive action links, very smart interfaces that you cannot bypass. We actually don't know in detail how they look like, but in part they are self-destructive. If you try to tamper with them, they will self-destroy in a way that the nuclear weapon cannot be set off any longer. So the only thing you could do with this is extract the fissile material and then build your own weapon.
I was just going to ask, once you create a weapon, how long is it viable?
So this depends on the weapon. The reason why it may not be viable is not that the fissile material decays too fast. The half-life of plutonium is about 25,000 years, uranium much longer. But the problem is that the radiation destroys electronics. The electronics only can take a certain amount of radiation. And that's why the United States needs a stewardship program where they routinely check out that all this electronics is still functional. And I don't know the frequency on which they do this.
Has the electronics gotten smaller in the computer age?
Oh yes, absolutely. But not necessarily more radiation hard. Yes?
What's the situation in North Korea and their development?
So I would prefer to say this at the end, because so definitely we know that they have nuclear weapons, and we also know that they're increasingly successful in launching long-range ballistic missiles. But it's difficult to say whether they're already able to load successfully a warhead like this on a ballistic missile and send it, for example, to Guam. I didn't mean to discuss this, but the challenges on the ballistic missiles are enormously. The acceleration that this warhead experiences both during launch and then during re-entry into the atmosphere are similar to a car driving at about 40 miles per hour into a concrete wall. It's not impossible to do this, but it's very hard. It's not trivial. Okay, now back to my problem here of being perfect. So what I want to point out is that there's a number of countries that have enormous numbers of warheads on ballistic missiles that are on trigger alert. They can be launched within a few minutes. So if there's an accident, for example, if our early warning detection system detects a false launch in Russia, there is the danger that the President of the United States might decide to launch this 900 systems. And by doing so, we would have an accidental nuclear war. Has this happened before? Well, I think it's actually quite appropriate to honor Stanislav Petrov, who is shown here on this picture. He passed away in September. This is an article that NPR had on its webpage. He was on watch at the control center near Moscow of the Russian early warning system in 1983, when all of a sudden 5 American missiles were detected. This was the worst possible time for this to occur. Tensions between the Soviet Union and the United States were at an all-time high. The Soviet Union had downed civilian American aircraft. The Soviet Union was very worried about major NATO maneuvers in Europe, which they somehow thought is a preparation for a war. So everyone was very nervous, and Petrov was very concerned that if he passed this detection on, that there will be at a certain level a fairly automatic response in launching a counterstrike. Luckily, Petrov actually was one of the main contributors to this early warning system, which was new at the time, and he knew that there may be certain flaws. So he decided that this cannot be real warning. One thing that was atypical is that it was only 5 weapons and not an all-out attack. This could have something to do with the EMP. Maybe the United States was trying to take out the Russian defenses with the EMP of the first 5 weapons. Luckily for us, he decided that it's a false alarm and was found to be true. Yeah. The other time where it's thought that we were really near a nuclear exchange was the Cuba crisis. So this has happened before. And I think the problem is we are not going to be perfect with this. Everyone will do her and his best possible job, of course. This is very important. But there will be a small probability of failure of a false alarm that's not identified as such. And then we could have an all-out nuclear war. So what would this do to us? And then I end. This here shows the arsenals as a function of time. End of World War II, this somewhere here is today. At the height, this was exactly the time of Petrov here, 1938. There were 70,000 warheads around the world. I show you in a moment, this is plenty to destroy the Earth. I guess not the Earth, but biological life, at least human life on the Earth. So what I want to discuss briefly today, I think both, according to the New START Treaty, the United States and Russia have 1,550 warheads left. The paper I referred to is actually dealing with the previous arms agreement, the so-called START Treaty of Moscow in 2002, where both sides still had 2,200 weapons. And I follow now a paper that assumes that there's an all-out nuclear war using this arsenal. So for illustration, to see how many direct casualties there are, the authors assumed that 1,000 weapons would be used with 100 kilotons each on both sides. And they find that this would instantly kill 20% of the US population and 30% of the Russian population. Here is a plot from their publication that shows people who are either killed or injured as a number of 100 kiloton explosions. One thing that's interesting here, we see that countries that have very dense population centers, such as China, would have way more casualties compared to countries that are spread out wider. But the numbers are absolutely enormous. So we are really looking at 100 million people in an all-out sword war to die right away. How about the rest of us? Let's say we are lucky enough that we were not in Chicago or we were not in Urbana-Champaign that will be hit for its computing infrastructure if there ever was an exchange. So let's say we were in southern Illinois. What are our prospects to survive? The problem with an all-out nuclear war is that it carries a lot of dirt and soot into the atmosphere. This author's estimates that in a sword war where this sword arsenal is used, this will be more than 200 million tons. This will reduce rainfall by 45% here in the Midwest. This will reduce the average temperatures by 14 degrees Fahrenheit, and it will really shorten the growing season, the period of time every year that's favorable for plants so that they can grow. In the Ukraine, where most of the nutrition in Russia comes from, there is no growing season left after such a hit on the climate. Here in the Midwest, I think this is for Iowa, we would be cut down to a quarter of the length. So we certainly couldn't grow corn or soy. That needs much longer time. It needs much higher temperatures. This is a plot that shows this. This is the amount of soot that's thrown into the atmosphere. This is the 200 million tons in an all-out sword war. And we see that the temperature, the blue I think is Iowa, the red is in the Ukraine. The temperature would drop by over minus 7 degrees Celsius now, 14 degrees Fahrenheit. And this is the change in rainfall. And it's interesting to compare this to the last ice age or the little ice age in the 1600s. So we should expect glaciers here, I believe. We had glaciers here during the last ice age. So this would be really very severe in its consequences if this was ever to happen. And then I think on this plot, one thing I want to show is how long it would take before we would return to more favorable conditions. It turns out that the half-life for soot high up in the atmosphere is about 5 years. So we then can figure out every 5 years we reduce the soot to 1/E, and it turns out that it would take about 20 years to return to conditions that were present in the little ice age in the 1600s. That still meant famine in Europe. So on the northern hemisphere, I think in the case of a war like this, we basically had to survive 20 years without agriculture. And all of a sudden, we may find that there's a wall in the wrong place as we try to go south. So I think I should end here.
But we certainly still have time for questions. And let's
okay. Yes?
Well, in addition to a thermonuclear explosion, they could use this nuclear material in explode in conventional fashion as kind of a dirty bomb, right? And just
Right. Right.
Is there a much greater chance of that?
That is absolutely right. If you look on this slide, this is what I wanted to discuss next. But people could take a regular radioactive isotope and combine this with a conventional explosive, and then explode this to spread basically the radioactive isotope. And I think if you were to do this in Chicago, you probably could turn a whole city block useless for extended periods of time. And it's estimated the amount of fear and interruption, is billions of dollars of economic damage. The loss of life is not that large. It would be similar to what you have in the explosion of a conventional bomb. So the consequences are much less dire in terms of loss of life, but economically they still were very serious. And this is actually an example where criminals, without knowing what they were doing, stole a container that had cobalt-60 from a hospital, and they made the mistake opening it and suffered serious radiation doses. But that is absolutely possible. And as you know, our hospitals are not guarded. Terrorists could obtain cobalt-60 here from Carl or any other hospital on the way up to Chicago. Yes?
So how far would you have to be away from ground zero nuclear warheads to have harmful amounts of heat or radiation or anything?
So I think this depends very much on the yield of the weapon. Like in Hiroshima, I think if you were away 1.5 kilometers and you were inside a building, you did survive. if Chicago was hit with a megaton weapon on a Russian ballistic missile, I think you have to be 5 kilometers away and inside a building.
Yeah, in 1943, the S2 committee, in what's known as the Grosse memorandum, this is the Manhattan Project, made the recommendation to use the byproducts, basically uranium hexafluoride, as a radiological contaminant, air, water, soil, and food. Since then, we have continuously done that, and we developed what's called uranium weapons, contaminating all over Iraq, Saudi Arabia, Kuwait, the Middle East, and Afghanistan, with horrific health effects on all the populations there and the U.S. military, with medical care as of this last Wednesday still being denied for those who are directly involved. So what has happened with over an estimate of probably 3,000 tons of that radioactive material spread all over, the terrorists have now been picking it up. And so they've got it readily available with conventional munitions to reuse it again.
Yes, but it cannot be used for nuclear weapons. This is depleted uranium. So
a substantial portion still of 235 in it, and what we found, they could still...
It's not substantial. It's not enough for a nuclear weapon.
Yeah, but not a nuclear weapon, but you don't have to have the nuclear weapon, because what we're seeing today is horrific health effects just from the radiological dirty bomb.
I know, but I think no one is apologetic about this. If anything, right now there's a big discussion how NATO should respond to the next generation of Russian tanks. There are countries that don't use depleted uranium ammunition, like German tanks, for example, use tungsten. But it's kind of thought that this new Russian tanks, the armor cannot be pierced by a tungsten projectile. So Germany is actually considering now to follow the United States and have depleted uranium ammunition. So that problem is not going to go away anytime soon.
How concerned are you about North Korea?
Well, I think we have to be very concerned about North Korea. I believe we can count on them being rational and wanting to survive as a regime. I think that all nuclear proliferation, asks the question: how much can these people avoid that this material is going to get into the wrong hands? And I gave this example where I suggested that North Korea might outright sell it if the regime survival is in danger. I think it's pretty much the last place where I want to see nuclear technology. Yes?
What was the elevation at which the Hiroshima bomb was exploded?
I believe it was exploded. Oh, at what elevation was the bomb exploded in Hiroshima? And I believe it was exploded about 600 meters above ground. And that is roughly the altitude where you will get maximum destruction. This may be a little difficult to see, but it has to do with the blast wave. We gave examples. Let's say I ask at what distance is my blast wave still 10 psi, because then it still will injure and unfortunately kill everyone. It will destroy all buildings. And if I put my bomb at that altitude, I make sure that basically on a sphere that covers the whole ground, I get this destruction. And I actually get less destruction if it explodes on the ground. Then I have this fallout problem, but the destruction to the city will be less. And what's done militarily depends completely on the context. For example, much of the ballistic missiles that the United States and Russia have are aimed at ballistic missile fields. They try to take out ballistic missiles on the other side. Those ballistic missiles are in hardened concrete silos, and in order to have the best possible chance to destroy one of them, they actually would hit them directly. So this would be not in air explosions. This would be at the ground level.
What was the general principle involved in engineering to reduce the size of these warheads so incredibly small?
So I'm not sure this maybe is known, the concept may be known publicly, But I think in detail, this information is classified, and for a very good reason. And I believe one thing one could say is what needs to be understood is the hydrodynamics of materials that are compressed by shock waves to reach the highest possible densities. And I think that's basically the science and technology where they made progress to reduce the weight dramatically.
Kind of a similar follow-up. What is the smallest amount of uranium-235? What's the smallest amount you'd have to bring together to cause a chain reaction?
So this again depends on the level of technology. I believe if for terrorists or a country that starts, it's at this 25, 27 kilograms. If it's metallic, if it's in oxide form, you need twice as much. And then, depending on the technology you master, the amount can be significantly less. Yeah, we can do all three. Why don't you start?
Me?
Yes.
Oh, in August 1945, I was a 15-year-old high school student, and we rejoiced. And then we thought, well, what happened if the Russians got it? So our high school had a assembly, and it was explained to us by the experts that Russia wouldn't be able to build a bomb for hundreds of years. We were so far ahead. And so we slept soundly that night.
Right. Yes, I'm not sure so I have Russian collaborators, and they are just as educated and knowledgeable as we are. To not trust Russia with developing technology seems to be unrealistic to me. Then furthermore, I think at the time, despite the growing divide between the East and the West, there were people who actually thought that this technology should be available to everyone. And some were motivated to spy and transfer this knowledge, as you know. So Klaus Fuchs, for example, who played an important role in the Manhattan Project, outright went and gave the secrets away. And I think that also contributed to the very rapid development in the Soviet Union, where I believe the first test was already in 1949. I think we have more the opposite problem now. If we don't interfere with diplomacy, with sanctions, whatever tools we have, this will spread further and further as technology advances and as it becomes easier to make fissile materials. Yes, please.
Some time ago, I remember hearing about, and I don't know if this was experimental or theoretical, but the neutron bomb, if it killed a lot of people but not destroyed anything. I wonder if that was ever developed, if anyone has that, or when they decide to do something.
Yeah, so the way you portray it, I think it may not have existed. So what you can try to do is you can try to reduce the amount of energy that goes into the blast wave and into the thermal radiation to be not as harmful to whatever structure you destroy. Maybe in a battlefield situation, you may want to use a nuclear weapon so that it kills enemy combatants, but then your own troops can pass through the area without being harmed. So I think there are designs in which the energy flow is redirected into the neutron output to some extent. I mean, it's still a mighty explosion. And these neutrons are very damaging. It's the most damaging radiation for biological life.
But it doesn't exist.
I think it did exist. It certainly was designed. We can do both.
So in the case of the German nuclear power plant blast, which happened right back, so there was the city is still under ruins. So how safe are the nuclear power plants which we have all over the world, and are the same security measures applied to these kind of power plants where they actually pose a lot of nuclear material, and can they also be accessible and can they also be used for destruction?
So I think the question has several levels. Like one is, can terrorists acquire nuclear materials from a nuclear power plant, and is the security sufficient to prevent this from happening? And there it has to be said that civilian power plants like our reactor in Clinton, they are not reactors that use highly enriched uranium. So there's no material there that could be used for a nuclear weapon. It still has to be guarded, and it is guarded, because someone could try to, for example, simply cause a major accident there, which would impact the area similar to what we have seen in Chernobyl. I think that in the United States, security levels and also Western allies are sufficiently high. Then another level of question is the operation of the nuclear power plant safe? And there I believe the idea is that, again, there's no perfect. There is a probability that major malfunction occurs. And I think depending on the design, like French versus US versus German, I think that numbers vary between 10 to the minus 4 to 10 to the minus 6 for an accident per year. But I'm not an expert, but it's relatively low. And so we should have accidents every once in a while, and that's what we observe. We have had Chernobyl, we had 3 Mile Island in the United States, and then Fukushima. It's the same thing. If anyone says this is not going to happen, I think it's just a statement that the person who says this doesn't know about statistics. There is a small probability that an accident occurs, and how often this happens depends on how many plants are operating. Yes?
This actually tags on to this question too. Regarding high-level nuclear waste that can be used for dirty bombs, could you comment on the safeguards around that? I'm sure it's less than high-level fissile material. Are you happy with how that's being safeguarded across the U.S.?
So I'm not an expert. I think I'm happy with how it's safeguarded at reactors. So for example, at Brookhaven National Lab, the research reactor is a high flux reactor, and some of the fuel elements are stored there for some time. And safety is massive. And then I think in the long-term storage, there's a mechanism that the waste protects itself in the sense that it's kind of lethal from the radiation levels to approach it, to work in there. So I think you need the proper tooling, and that's not trivial for a terrorist. But I don't know enough really about the safety there. Yes, in the back? So I don't think that one can neutralize the bad effects. I believe that evacuation plans are probably the best way to go. I don't think there's anything adequate for all-out nuclear war. And there are plans, I believe, for singular attacks, terrorist attacks. Yes?
You mentioned that 4 Russian subs carried nuclear weapons and been lost. Do you know if they've all been located?
I don't want to be, my answer is going to be, I hope they won't locate them. Because maybe if it's the Russians or the Americans locate them, that's fine, and recover them. But I think we certainly would have done so if we knew where they are. And I wonder to what extent in some future, as submarine technology becomes available to others, someone might find this first whom we don't want to find. That's a good question. Yes?
How long approximately does it take to build a nuclear weapon?
So it depends on where you start. So if you have the fissile material for a terrorist organization that hires the necessary staff, engineers, technicians, scientists, maybe a dozen people, it's thought that it takes about a year. Then for an entirely new player, who needs to mine the ore, who needs to separate the uranium from other rare earth elements, and then enrich, the time is much longer. I'm not sure, it really depends on the resources that the country has. But one thing that maybe will help, in 2003, the IAEA reported that Iran is in violation of the NPT. And then by the time the joint plan of action was negotiated, the predecessor of the Iran nuclear deal, I think this was in late 2014, Iran had enough low-enriched uranium at 20% for 8 or 9 warheads, and it would have taken them 2 months to turn this into a weapon. So I think if you start from scratch and you really want your own genuine program, it probably takes decades. Yes?
Just as a nuclear weapon for a long time. So what will happen if you explode the nuclear weapon which was stored for a long time? Is that really going to explode, or is it going to deteriorate, or what?
I believe the main thing is that you have to look at the electronics, that the electronics is still viable and operational. And I think that this needs to be checked fairly frequently. Maybe this is a number I don't know. I don't think they tell us, but I'm sure they do this annually or something like that. They may also have a program to just replace certain fragile components, so electronics that's particularly susceptible to radiation. Yes?
I don't mean this to sound political today, but I'm a little concerned, and I'm asking you a question about your concern, that a large number of people are being placed in positions of power in the administration who are not science people in positions that would appear to need people with science backgrounds. Does that concern you?
Well, it concerns me enough so that I think there's only one PhD physicist in all of Congress. And he happens to be from Chicago, right? Aurora, I think, that district, Bill Foster. And clearly, we should be concerned about this. One thing, though, that I see is, and I'm not sure to what extent this is changing, there are fantastic tools members of Congress have at their availability. The Congressional Research Service is absolutely excellent. If you read what they have to say, for example, about the Iran nuclear deal or North Korea, this is first-rate information. The people who do this have the necessary scientific, engineering, security background. All it takes for a member of Congress is to be smart and to be able to listen to these people. And then there are many other forms of information, of course, they have as well. One thing I would be very concerned about is if there are people in leadership roles who, for whatever reason, do not listen to what these experts have them to say.
It'd be terrible to be at or near ground zero, say, in Los Angeles, if nuclear missile or bomb were to hit there. But when we talked about the EMP issue, just a couple of strikes of our power grid or satellites appear to be much more dangerous to the population of our country than nuclear devices going off, airburst or at the ground.
Yeah, so I think that you're right, and it was commented before, we probably don't appreciate enough the dangers that come from the EMP. And interestingly enough, the North Korean leader referred to this when he presented his last weapon, the thermonuclear device, apparently. He claimed that this also could be used for an EMP attack on the United States. I think what this would do is it might take down our power grid. I think where this would affect everyone immediately. There's certain places where it's critical in nuclear power plants, in hospitals. So I think there needs to be investment in backup power and in emergency plans. So it's entirely possible that in American hospitals, many people would die who depend on electricity being there. That's correct.